Hello there, you beautiful people, and welcome back to the second part of our discussion about making your very own bash script. And in this video, we're going to make another bash script that's going to allow us to back up all the folders in our home directory, and we're also going to show you how you can set up your bash script so they can be run in a more convenient way. So let's make another bash script. We're going to call it backup.sh on our desktop. So we're going to type nano then backup .sh, and in there we're going to add as the very first line our shebang line, and our shebang line tells the shell to not read this file as a text file, but instead to interpret it as a bash script. So the way we do that is we type a hash then a bang, so a hash and then an exclamation mark, and then the path to the interpreter that we want this file to be interpreted with, and that is going to be our bash shell, which is located at /bin/bash, and we can check that if I close out of that and you go back to our command line by typing which and then bash, and we can see /bin/bash is where the bash interpreter is located. So with that, if we open back up our backup script, we can now underneath here start writing commands that will make up our script. Now we want this script to compress and archive all of the folders inside our home directory, or at least the downloads, documents, desktop, pictures and videos folders, because they're the best. So let's see how we might do that. Okay, now if you remember from what we learned at the end of the last section, to make this happen we'll need to use the tar command, and we need to give it a few options. So for example, we'll give it the C option to create a new archive, the V option to make it speak to us, and the F option to tell it that the next argument is going to be our archive file, and we're going to call it backup.tar.gz. Okay, but to make it compressed using gzip, we actually need to give it the Z option as well. So we're going to compress it through gzip into a file called backup.tar.gz. But now we need to tell it what we want to actually store, and this is what we're going to tell it. We're going to say, hey, I want you to put in there, we want to put in there everything in our home directory. We're going to put in our documents folder, our downloads folder, our desktop folder, our pictures folder, and our videos folder. Okay, so what we're saying here is, hey, use the tar command, compress it, be verbose, tell us what's going on, zip it through gzip, and make the file called backup.tar.gz, and inside there put the documents, downloads, desktop, pictures and videos folders from our home directory, using a bit of brace expansion to save us some typing. Okay, so that's it. Okay, and now when we run our bash script, if we do bash backup.sh, you'll see that it's given us some output, and now we've got a backup.tar.gz file on our desktop. So isn't that very cool, right? And you can see here all the files that have been added into the backup folder. Now in there we gave it the V option here for verbose, and that's why we got to see all that output on the screen. Maybe we don't want that, so if we just get rid of the V, and let's say we remove backup.tar.gz, and now we run it again, you can see that now we don't really have as much output from it, but we've still got the backup file. So you can see here one benefit of writing these things in scripts. You can save and edit the behavior of those scripts over time as your needs evolve, and they're always going to be there for you to run. For example, we might not like the fact that this message comes out on standard error, so we can just go back into our backup.sh and redirect this command standard error to a place called /dev/null, which basically gets rid of it. Okay, so there we are. We've redirected standard error to /dev/null, which is a place on the file system called the bit bucket that basically just deletes whatever is sent to it. And now if we try to run bash backup.sh, clear the screen, we run it now, we notice that we can now get no output. But if I delete this backup archive and run it, you can see that the backup is still created, but now we don't get any error. So you can see that you can customize these scripts as time goes on. So what I want to draw our attention to a bit right now is how we can make running the bash scripts a bit more efficient and user-friendly. So at the minute, what we're doing is we are on our desktop where the bash script is located, and we're typing the bash command and then giving it the path to the bash script, which at the minute, because we're already on the desktop, is just backup.sh. When I run that, we get the required output. But that's kind of a bit of a hassle, because if we weren't on the desktop, then we would have to give it a different path and we have to run the bash command. There's a better way to do it in just one step, okay? And this is how you set that up. So what you do is you go back to your home directory, and you can see in here that we've just got our normal folders. But what you do is you make a directory called bin, all in lowercase, okay? Bin. And you can see that that's been created, and what you do is you move all of your shell scripts into that folder. Let's move from our desktop the backup.sh file. So backup.sh, we're going to move it into our bin folder. Okay, so we're moving from our desktop the backup.sh file into our bin folder. Okay, so you see it's been moved from there, and when we now go into our bin, we see that backup.sh is in there. And actually, I'm just going to rename it from backup.sh into just backup. Okay, so now we've just got the same file called backup, and if I run it, it'll still work, so there's nothing wrong. I've just renamed it a little bit. Okay, now I need to make this so that it can be run from the command line. Okay, so what we're going to do, there's two ways to do this. First of all, we can open up in our file browser, we can go into bin, and then we can right click properties, go on permissions, and then click allowing executing file as program. Okay, that's one way to do it, but I'm not going to do it like that for now because I want you to learn the terminal way. So what you do is you type the chmod command. Now the chmod command stands for change mode, and what it does is it allows you to change the permissions that a certain file has. And then as a second argument, you type +x, which means give it executable permissions, so add executable permissions, and then you tell it the file, so just backup. When I run that, so what we've done is we've added executable permissions to the backup. Now when I look at it with ls, you can see that it's gone green. Okay, so that means that it can be ran as a script. Now the cool thing about this is if we close actually what I'm going to do is as well, just to make it a bit clearer, if I go back into backup, what we're going to do is I'm going to make sure that the backup is always saved on the desktop. Okay, that's just going to make it a bit clearer to demonstrate what's happening. So what we're going to do is I'm going to close the terminal. I'm going to delete our backup here. Okay, and now notice I'm in our home directory. Okay, but if I type backup, we can see here that we're getting an error saying that the backup program is not currently installed. Now, if you remember what I told you a long time ago, right at the start of this course, when the shell says it can't find something, that means it's not on the shell's search path. So we need to edit the shell's search path to include our recently created bin folder. Now, the way that we do this is we're in our home directory. If we go ahead and use the nano command, I want you to edit the .bashrc file. So the .bashrc, no spaces, all lowercase, will open up this very important file. Now, if we scroll all the way down to the bottom and add a line down there, this is what I want you to write. Okay, I want you to write path in uppercase, then an equals sign, then some double quotes, so 2 double quotes, and inside those double quotes, $path, a colon, then $home in uppercase /bin. Okay, so let me explain this a little bit. So what we're saying here is a variable called path. We're going to set our path equal to what the path currently is, then a colon, then our home folder /bin. So the bin folder in our home folder is going to be added to the path. And when I close that, we write to the bashrc, close it. Now if we close our terminal and open another one, what that has done, if we echo the path, what that has done is it has added /home /zad/bin to our path. Now that means it'll be able to search for our backup script in the path just like it would any other command. So now when I run backup, you can see that our script has just been run and it has now created the backup. So if I now go into our bin folder and I create another file called hello, for example, and in there I tell it that it's a bash script with the shebang, and I say echo hello world, okay, and save it, and then I give the file executable permissions, so chmod +x hello, see that it's gone green. Now I can be anywhere in my file system. I could be in my documents folder, okay, but if I run hello, you can see that hello world now works, and I can pipe these to wherever I want to redirect them. So if I redirect it to a file called hello.txt on my desktop, there we are. We've now got a file called hello.txt on the desktop, and we're now basically creating our own commands. So isn't that awesome, right? Like we've got our own commands, and anything that we put in this bin folder, if we give it executable permissions, we can run it just like any other command. So that is incredible. But now you might be thinking, okay, Ziad, this is cool and everything, but what's really the difference between an alias and a script? So remember, aliases are things that you put in your bash aliases file, this .bash aliases file. And if we take a look in there, what we're doing is we are, setting command names, and we're giving them what those commands mean. Why didn't we just make an alias and we say backup equals tar/cvzf to our desktop, and then put backup.tar.gz and say we want our desktop and our documents and our downloads and our pictures and our videos, and then close it. Why didn't we just do that, Ziad? Like we know how to make aliases. Wouldn't that work the same? Well, yes, it would work the same in this instance because we have a one-line script. Okay, I'm going to close that. We're not going to do that. That's because we have a one-line script. So aliases can become, are the same as one-line scripts, really. But the good thing about scripts is that scripts are designed to contain more than one command line, whereas aliases are usually just to give more convenient names to just one command line. Now, secondly, scripts can have more complicated programming constructs, such as loops, if statements, and functions. Now, if you've never done any programming before, suffice it to say that scripts are more heavy-duty than aliases can be. Okay? And thirdly, scripts can be scheduled to run at any time using cron. And that scheduling part is what we're going to focus on in the next video. So over the last couple of videos, you've seen how to create your very own bash scripts, and the key about bash scripts is that they allow you to store useful command sequences in files that you can use later on. Now, because anything on your computer is changeable and editable through the command line, and because you can save these series of commands that can do specific functions, you can create incredibly powerful bash scripts that can do whatever you want and save those bash scripts for later by using the fundamental skills that you've learned in the last two videos. Now, a key piece of information is that bash scripts must have the shebang line telling them that the file needs to be interpreted as bash commands using the bash shell interpreter, which is located at /bin/bash. Now, this shebang line is the first line of every script, and there mustn't be anything above it, and there mustn't be any spaces in the shebang line, the text that's highlighted here in orange, so it must come just as you see it there. And it's the shebang line that turns your regular text file into a bash script and tells the shell to interpret everything in that file as bash commands. Now, if you wanted to make a Python script, you could put as the shebang line something like hashbang/user/bin/python3, and that would allow the script to be interpreted as a Python program. But this is how you do it in orange here for bash scripts. Now, you've also seen how you would make scripts runnable just like regular commands, and you saw how you would make a bin folder in your home directory and add each script to that bin folder. You would then give each of the scripts executable permissions using the chmod command and add that bin folder to your shell's path by editing your bash rc file. Now, this allows you to run scripts just like regular commands. So we type backup and our backup script ran. We typed hello and our hello script ran. And this will also work for Python programs as well. Now, as an aside, if you're interested in learning more about the Python programming language, then go to the last video of this course where you'll have some discount coupons for all my courses, including my best-selling Python course, The Python Bible, which will take you in a project-based way from absolutely no previous Python experience all the way to writing 11 Python programs. So if you're interested, go ahead and check that out. But the bottom line is that scripts are more powerful than aliases, and scripts that can be run at any date or time that you like, which allows you to automate your workflows. And it's precisely that scheduling that we'll be coming on to in the next video. So in the next video, you're going to learn the true power of shell scripts by learning how to automate them using an incredibly useful utility known as cron. So to learn how to schedule automated tasks, I'll see you in the next video.